Hello, and welcome to my channel, Reading Little Blue Books Out Loud. This is a little blue book. It happens to be Little Blue Book number 409, and is entitled Great Men of Science, written by Howard Carrington, PhD. Let's see if it has a copyright date. I'm sorry, this is Heward, H-E-R-E-W-A-R-D. Hereward Carrington, PhD. Ah yes, copyright 1924. So this book is about great men of science, according to the year 1924. Table of contents: introductory classification of the sciences, general science, astronomers, chemists, physicists, biologists, evolutionists, physicians, practical scientists, and mathematicians. And we'll get started right away. Great Men of Science introductory. What is science? It has been defined as an organized body of knowledge. In a certain sense, this is very true, but in another sense, it is not. The facts which formed the science of yesterday are by no means the same facts which constitute it today. All conclusions seem to be tentative and provisional, and the so-called facts of science are changing constantly. It is absolutely true that any textbook on science more than 5 years old is out of date. New discoveries, new inventions are constantly being made, which materially alter our outlook upon the world and change our very conceptions as to the nature of the world in which we live. Then, what is the use of such science? It may be asked. It has enabled us to know everything which we do know about our own sphere of activity and the universe in which we dwell. If the facts of science are constantly changing, the method is not. Science, then, is essentially a method, and those men of science who have helped to formulate this method and utilize and apply it are the ones who have helped most in laying the foundations of true knowledge. Isolated scientific facts in themselves have great value, for upon them our information is built. But before they can be utilized and applied, they must be welded together into consistent whole. I should say into a consistent whole. They must be shown to have some relationship one to another. Some theory or hypothesis must be formulated, which permits all these facts to fall into rational and systemic order. The experimental scientists are those who discover isolated facts. The philosophical scientists are those who utilize them to construct a world philosophy. Now and then, some great genius comes into the world who combines both these essentials, who is capable of laborious and accurate research, and who is also capable of seeing meaning of all these facts, and of dovetailing them together and constructing a beautiful mosaic of the whole. Then we find a great man, such men as Darwin, Newton, Bacon, Spencer, or Aristotle. I should define a great man of science, therefore, as one who not only makes ingenious and original researches, but as one who sees the philosophical import of his work, and who is capable of formulating generalizations and laws covering not only these facts, but many others, and offering us a certain inside viewpoint upon life and the universe in general. And if we look back upon the great names of history, we shall find, I think, that this definition is amply borne out. All those men whose names stand preeminent are those who have been philosophers as well as mere experimentalists. The present age of extreme specialization may have modified this view to some extent, but up to the present time it has been essentially true, I am convinced. So far, so good. We have defined science and the characteristics of great men of science. They are those whose life work has given us some new outlook upon life and the universe, and which has to a certain extent altered the evolution of the human race in consequence. And yet some science can hardly be said to have this practical effect at all. Take astronomy, for instance. Apart from a few isolated instances, it can hardly be said that the details of astronomical research affect the human race very essentially. Yet, it is one of the most exact of all the sciences, and has revealed vistas undreamed of before. Because of it, we are enabled to interpret our universe in a very different way than we could without its aid. Philosophy and even religion have been profoundly affected thereby. Here we have an example of pure science which, when rightly understood, has been found to have a tremendous influence upon human life, but it is not its facts so much as the inferences drawn from these facts which have done this. Again, we see the necessity for both essentials. We are now in a better position to judge and appreciate perhaps the characteristics which must be possessed by any truly great man of science, and what he must accomplish in order to deserve his title. But one more question here presents itself. What may we include in the general category of science? What studies may be classed as essentially scientific and what may not? Our first thought, the answer to this question appears to be simple enough. Physics, chemistry, astronomy, biology, geology, physiology. These are all easily distinguishable and characteristic sciences. But there are other branches of learning and knowledge which are not so readily classified and determined. Take anthropology, for example. May this be classified with the sciences? If so, what about sociology, economics, history? Are these to be included, interrelating as they do with our general topic? We are accustomed to describe this man as a historian and that man as an economist, and not as a scientist in our original meaning of the term. Take again psychology. Is this a science in the same sense that physics and chemistry are science, dealing as it does with invisible mental processes and reactions? And its still more dubious and younger sister, physical research, is that a science, or is it not? Then there are various subdivisions of the more general sciences, oceanography and paleontology, for examples. Is the mathematician a scientist? Is the inventor and the man who deals entirely with practical and applied sciences? Are not some of the great philosophers who have embodied scientific concepts in their writings, such as Goethe, Kant, Bergson, are they not scientists also? We are accustomed to speak of them as philosophers and not scientific men, and we speak of medical men as physicians and not scientists as a rule. It is very evident then that it is no easy matter to determine the precise status of a scientist. It is not such an easy matter as might appear at first sight. Provisionally, however, for the purpose of this little book, I shall define a scientist as a man who adds to the sum total of human knowledge by reason of original research in some specific field of the inquiry, and a great scientist as one who not only adds to our knowledge in this manner, but also wields existent knowledge together and deduces therefrom some philosophical principle of universal application, or who discovers some cosmic law of considerable importance. Bearing such principles of judgment in mind, then, who are the world's great scientists? Those who have fundamentally influenced and shaped men's lives and thoughts, or who have discovered laws and principles of first-rate importance? Once again, we must pause and reflect. Before arriving at any too speedy a conclusion, one might compose a list of a dozen names, e.g. of great men of science, such as Aristotle, Francis Bacon, Darwin, Galileo, Newton, Copernicus, Einstein, Kepler, Herschel, Euclid, Archimedes, Dalton, Laplace, and offer a summary of the lives of these great men. Yet such a list would obviously be far from complete. What of Roger Bacon, the father of experimental science? Of Lamreich, one of the founders of the theory of evolution? Of Lyell, the first great geologist? Of the Curies, the discoveries of radium? Of Mendel, whose work so influenced modern views on heredity? Of Harvey Galvani, Marconi, Pasteur, Lord Lister, Sir J.J. Thomson, William James Finson, De Vries, Galton, Carroll, Bessemer, Steinach, Culver, Haeckel, Roentgen, Paraguay, Bell, Freud, Lodge, Voltaire, Hinton, Fulton, Burbank, and a host of others whose discoveries have not only profoundly influenced our lives and civilization, but have also influenced the whole trend of scientific research, and rendered possible many later discoveries which were only made because of their pioneer efforts. It would obviously be unfair to omit these names altogether from such a list. On the other hand, it would be impossible to include within the modest dimensions of this book every name worthy of special mention. I have been forced, therefore, to adopt the following general plan, which will, I trust, be found serviceable. I have first of all classified the various branches of science, including each sub-science under its general head. Thus geology would include paleontology, etc. I have then given a brief account of the life and work of the most important men in this field, following their names by others of lesser importance. Enumerating briefly the achievements of these men, such an arrangement will, I trust, prove at once intelligible and useful. Pardon me. We must now finally make a brief classification of the sciences. We have first of all astronomy, then geology, physical geography, paleontology, oceanography, physics, astrophysics, mechanics, engineering, chemistry, metallurgy, mineralogy, agriculture, meteorology, biology, zoology, botany, physiology, logic, ethics, mathematics, statistics, sociology, ethnology, anthropology, science of history, economics, education, medicine, hygiene, sanitation, metaphysics, philosophy, religion, physical research. The above classification is probably fairly complete. Indeed, a few of these subtopics may doubtfully be included in such a list. However, if we aim to cover the whole field of human thought and activities, the above list may be found useful by way of general summary. In the following book, it has been impossible to make so many subdivisions, and a more unified plan has been sought. Thus, geology should undoubtedly have a separate section. but there have been so few great geologists, men, i.e., who have influenced the whole trend of human life and thought, that Lyell's name has been included, together with those of certain paleontologists, in the section devoted to biology. Botany and zoology have likewise been classified under biology, and so forth. On the other hand, it has been found somewhat difficult to distinguish between biologists and evolutionists. An attempt has been made, nevertheless, and when necessary, mere reference to a name has been made in one section, and a more extended account of his life and work in another. I have begun by enumerating the most important men whose names are associated with the advancement of general science, following these by sections in which accounts are given of great men associated with the development of astronomy, chemistry, physics, biology, evolution, psychology, medicine, practical sciences, i.e. applied science, and mathematics, respectively. Great men of science. General science. It is generally conceded that Aristotle possessed the greatest all-round scientific knowledge of any man of antiquity. He lived 384 to 22 BC, and was for a time the instructor of Alexander the Great. He made vast collections in the departments of botany and zoology. He wrote on politics, ethics, anatomy, physiology, metaphysics, botany, biology, hygiene, poetics, metaphysics, and covered all those topics in a remarkably comprehensive manner. His word was law for centuries, and his ethics and logic remain today perfectly sound. He wrote on the theory of knowledge and the nature of reality with the same insight as he did upon physiology, and although many of his ideas appear erroneous or even absurd nowadays, the product, taken as a whole, is one of the most remarkable in history. Archimedes, 287 to 212 BC, has been called the greatest inventive genius of antiquity. He was a mathematician, but also a scientist of remarkable ingenuity. He discovered the principle of specific gravity, the principle of the lever. He experimented with optics and hydrostatics and pneumatics. He devised pulleys and windlasses, catapults, the screw pump for water, the endless screw, various hydraulics and compressed air machines, and many others. His was truly a remarkable genius. Thales Hero, Ctesias, and Pythagoras were all noted names of antiquity, connected with scientific and mathematical research. And then, for centuries, the voice of science was stilled. Not until Roger Bacon, circa 1210 to 93 AD, was any great man of science produced in Europe, and Bacon, as we know, lived in terror of his life, and had to conceal his scientific research in a cipher code, which remained for centuries hidden to the world. Only later has this been read, and we know now that he possessed some form of improvised microscope, and was a man of immense learning. His namesake, Francis Bacon, 1561 to 1626, was also a scientist and philosopher. His Novum Organum, seeking to supplement that of Aristotle, his essays on Justi famous, as is likewise his New Atlantis, and there are those, as we know, who contend that he was the author of the Shakespeare plays. Fittingly, although he died as the result of an experiment which he was conducting. Sir Isaac Newton, the formulator of the theory of gravitation, and the first to decompose sunlight into its primary colors, is a name so well known that it will be hardly necessary to do more than refer to it here. Newton was born the year that Galileo died and lived until 1727. He was a great mathematician as well as being a philosophical scientist. His great work is the Principia, published during his lifetime. Benjamin Franklin was the first to suggest that lightning is nothing more than a gigantic electric spark. He also offered the first rational explanation of the action of the Leyden jar. Swedenborg, 1688 to 1772, is generally known as a mystic and visionary theologian. Such is, however, far from being the case. He was a learned scientist who wrote extensively upon cosmology, physics, physiology, psychology, etc., as well as being a courtier and a man of the world. Some of his works upon astronomy are even now consulted. It was only during his later years that he became a seer. His scientific writings possess high value. Helmholtz, 1821 to 1894, while primarily a physiologist, carried on experiments in optics, acoustics, chemistry, mathematics, electricity, magnetism, and practical mechanics. He contributed a number of valuable papers upon all these topics. His great work, Physiological Optics, was published 1856 to 66. Alexander von Humboldt, 1769 to 1859, was also a man of all-round genius, and his scientific activities were many and varied. He was also a diplomat, explorer, and traveler. The Humboldt Library of Science, published for many years, was named after this illustrious man. Professor Samuel Langley of the Smithsonian Institution was not only the first to experiment with practical flying machines, but invented the bolometer, an instrument which registers the 100th millionth of a degree of temperature. By means of this instrument, he was enabled to chart the rays of the infrared region of the spectrum. Although he did not live to see the aeroplane, a practical device, he nevertheless was instrumental in demonstrating its future possibility. Professor Chunder Bose of Calcutta first proved certain similarities between living and dead things, e.g. the fact that metals become fatigued. He also registered the life reactions of plants by means of delicate recording instruments. J. Arthur Thomson has written several solid books along the lines of biology, including Heredity, and is the compiler of the now famous Outlines of Science in 4 volumes. And I believe we will stop there, for that is the end of the chapter. Yes. That's the end of part 1.